All right. So let's look at the syllabus points that we have to know in order for us to start under polymer. What we have to learn, let's see. Okay, so first is you have to know how to define polymers. The definition is it is formation of large molecules built upon small units called monomers. So polymers is the one which is formed when combining with small molecules called monomers. And we have to understand the difference between polymers as compounds which have different units or different linkages. So we will be specifically learning about the linkages or the units. So under polymers, the first is the definition. The definition is says that polymers are large molecules built by linking 50 or more smaller molecules. You don't have to mention the specific value. So you can just mention polymers are large molecules that are built by combination of smaller molecules called monomers. So the keyword is monomer should be there in the explanation, in the definition. Since polymers are large molecules, in chemistry, large molecules are considered as macromolecules. And each repeating unit is connected to adjacent unit via covalent bonds. So that means when monomers, when they react, one monomer or one smaller molecule to another smaller molecule, they are connected by covalent bonds, since all are nonmetals. Some polymers are called homopolymers, which means they contain one type of unit. Example, polythene, polythene, from polythene, polychloroethene, which is also called polyvinyl chloroethene or PVC. So polythene is made from ethene only. That's why it's mentioned one type of unit. All right. So if it contains only one type of monomer, then it's called homopolymers. Polychloroethene is made from chloroethene. Okay. Other type is called copolymers, which means the monomers have different types. So for the monomers, different types of monomers are used. For example, nylon, terylene, and proteins, some biological natural polymers. So nylon is actually made from carboxylic acid plus something called an amine. So it is a two different type of monomer. Proteins are made up of different amino acids, different types of amino acids. Sometimes same type of amino acids combined with another kind of amino acid. So different kind of proteins are made in different way. So the idea is if the polymer is formed from same type of monomer, then it is called homopolymers. If it is different type of monomers, they are called copolymers. All right. Different linkages also exist. So we will be highlighting what are linkages as well, depending on the monomer. In your syllabus, you have to know amide linkage and ester linkage. Okay, amide linkage and ester linkage. If it is an amide linkage, it will have nitrogen hydrogen single bond and carbon oxygen double bond. This part, if it is there in a structure, it is called amide linkage. Ester, you might have come across during carboxylic acid esterification. So you have to be thorough with esterification as well. If it is an ester, it will have carbon oxygen double bond and carbon oxygen single bond as well. So if this part is there, it is called an ester. Inside the structure, if the C double bond or single bond O is there, then it's called ester linkage. Any student disconnected? Okay. So as you can see from these pictures, the first one so the first one, it is mentioned as this test tube. There's a test tube contain ethene gas. So inside the test tube, it is ethene gas, which is heated to 50 degrees Celsius at few atmospheric pressure over a special catalyst. It turns into a liquid that cools to a waxy white solid. This is found to contain a very long molecules. So we are heating ethene. That means ethene molecules inside the test tube combine together to form a white solid, a waxy white solid, which is a very long molecule. So which means there is polymerization going on. So when ethane molecules combine, it forms polythene, and it is really useful because polythene, as you know, most of the plastics is made from polythene, like toys, dustbin, plastic tables, chairs, pipes, buckets. Many our household material is made from plastic. Um, if you look at this structure, there are 1, 2, 3, 4, 5, 6 ethene molecules, right? 6 ethene molecules. If you are to combine these 6 ethene molecules, what do you think will happen first inside the ethene molecule? What do you think will happen first? Can you guess? Can anyone unmute the mic and answer the question? No idea?
The double bonds will break.
Very good. That's the correct idea. So if you take a look at the ethene molecule, you have carbon-carbon double bond, 2 carbon and 4 hydrogen. Uh, the rule of any structure in organic chemistry is each carbon should have 4 bonds. This point is very important. Each carbon should have maximum and minimum 4 bonds. So if you look at this ethene molecule, right now each carbon is having 4 bonds, right? So for the first carbon, you have 1, 2, 3, 4, and the second carbon, you have 1, 2, 3, 4 bonds. So fine, all the bonds are there, right? But what will happen if the double bond is broken? If the structure, if the double bond of the carbon is broken, which means each carbon is having 3 bonds now, right? 1, 2, 3 for the left side carbon, for the right side carbon also 1, 2, 3. As I mentioned before, a carbon should have 4 bonds in order to gain stability. So which means each carbon will have space to form 1 bond. So for the right side carbon, it will have space for 1 bond, and the left side carbon, it will have space for 1 bond, which means it will react with other molecule of same alkene molecule or ethene molecule, which its double bond being broken. So this, the first alkene molecule start to form bond with the second alkene molecule in this manner, and it goes on until all the alkene molecules are reacted. Okay, can you, okay, so we will proceed. So in this manner, one ethene molecule reacts with other ethene molecule by breaking the double bonds. So if you are to draw the structure of the large molecule which is formed when all these ethene molecules combine, we don't know how many ethene molecules is there. So there is a specific way to write the or to draw the structure of the polymer. But in this, the simple idea is, in this example, all the ethene molecules are added, right? You have 1, 2, 3, 4, 5, 6 repeating units. 1, 2, 3, 4, 5, 6. This is the structure of a polymer. This is a polymer with 6 repeating units. Okay. It's a polymer with 6 repeating units. So sometimes the question asks to draw the structure of the polymer with 3 repeating units, 4 repeating units. If you ask if you ask that question like that, this will be the way that you have to represent the answer. But there will be sometimes asked to draw the exact structure of the polymer. In that case, the way you write the answer will be different. Okay, so for example, we will highlight how to draw uh, different kinds of polymers. But before we go to drawing, we need to know there are two kinds of polymers. That is synthetic polymer and natural polymer. Under synthetic polymer, we must know that uh, synthetic polymers are man-made polymers, and there are differences to different types of polymers. Those are condensation and addition polymers. So we have to learn how to draw the structure of the polymer. If the monomer is given, we have to learn how to draw the monomer if the polymer structure is given. So in this case, we have some examples: nylon, terylene. The structure we need to learn how to draw. And most of the synthetic polymers are factory made, so used in clothing, fabrics, textile industry. So these are some of the key ideas, just few uses of synthetic polymers. And if you take a look at this idea, the polythene, you know, the polymer name polythene, the structure, as you can see here, it is a bracket N. So this structure is deduced from the monomer, meaning if you were to name, first let's focus naming. If you were to name the monomer, and then if you were to name the polymer, if you know if in the question the name of the monomer given, what you do is we include poly in front of the monomer name, and then we include a bracket with the monomer name. So ethene, polythene. If it is propene, polypropene. If it is butene, polybutene. It goes on in that manner. Okay. So if you take the structure for ethene, this is the structure. And if you are to draw the structure of polythene, what we do is we first write the 2 carbon as the base carbon that is having the double bond in monomer, but without the double bond. So when the double bond is broken, there will be continuation line for both sides, which means that the same structure inside the middle, 2 carbon and 4 hydrogen will continue from right side and left side. And then what we do is we introduce a bracket and end. Okay, let's take another example. Here, in this case, instead of ethene, let's take propene. So for propene, the name will be, so we include poly inside the bracket, propene, so polypropene. And when you draw the structure of propene, it will have 3 carbon, double bond at the last carbon, then all other hydrogen you can, right? This will be the displayed structure. But when to draw polymers, it's best if you take the 2 carbon that is having the double bond. Okay, so when you take the double bond carbon, the structure will be, and we take all other bonds at the top or bottom. So we have the hydrogen bond at the top, and from the bottom we have this CH3 bond. Okay, we are writing the exact structure, but we are writing in a different manner. That's only the different part here. So we write CH3 in this manner. Same structure, CH3, CH2, CH2, CH, CH2. So it's still propane, but we are taking the carbon-carbon double bond as the base carbon, everything else as branch. So that means when we draw the polymer, it will be very easy. So polymer structure will be, we take the carbon-carbon double bond as base carbon, we take the continuation line at the top, we take hydrogen, and then at the bottom, we take CH3 and all other bonds in this manner. We include the bracket and N. Okay, did you understand how to draw polymer structure?
Yes.
If alkene is given, this is the way. If the monomer is an alkene, this is the way we draw the structure. Okay, so let's take 5 minutes break and then we will start at uh, 2 o'clock with Imaduddin students. Other students, we have some new students joining with us today from other school. So I have taught them the addition polymerization, the key parts, the fundamental parts of polymers. So those will be recorded and uploaded. So as we mentioned yesterday, there are 2 types of polymerization. That means how polymers are formed depends on 2 type of reaction. That is, one addition polymerization, the other one is condensation polymerization. For the addition polymerization, the monomer in which to form the polymer, the monomer should contain carbon-carbon double bond. So the way you identify an addition polymer is by having an information about the monomer. If the monomer is an alkene, or if the monomer has carbon-carbon double bond, then the polymer will be an addition polymer. Then one of the usually in addition polymerization, the first thing happen is the carbon-carbon double bond gets broken, and each of the adjacent alkane molecule will be combined. So that means when the polymer is formed, the polymer will have only single bonds. Many polymers can be made by addition of alkene. Alkenes, they undergo addition reaction. So if sometimes alkane molecules, that is compounds that contain carbon-carbon double bond, sometimes they have chlorine, sometimes they have hydroxyl group as well. So for example, an alkene ethene molecule usually will have 4 hydrogen. So instead of 4 hydrogen, sometimes it may contain 1 chlorine, or instead of chlorine it may contain a hydroxyl group. So it depends on the structure given in the question. But still, the way you write the polymer, the steps that you have to follow will not change. Okay. So as mentioned, when you name the polymer, we add polymer and we mention the monomer inside the bracket. We mention poly in front of the bracket. So the prefix will be poly, the suffix will be inside the bracket, the monomer name. For example, if propene is used as a monomer, then the name will be polypropene. So this is an example. If you are asked to write an equation for the addition polymerization of ethene, so what we do is we mention N in front of the alkene structure and then arrow, then we mention the structure of polymer. So polyethene. Then like that, if it is chloroethene, chloroethene means in an ethene molecule there is 1 chlorine atom, so the name is chloroethene. N means the number of the molecule, number of chloroethene molecule, like ethene, number of ethene molecule. Then we represent an arrow and polychloroethene. Okay. Some students are getting online late. So usually a polythene for packaging is made and sold as pellets, as you can see from the photo. Later they will be heated to soften or uh, or melt them and turn into plastic bottles and bags. So this is what we highlighted yesterday. And these are the some of the examples of addition polymer. So you have monomer, chloroethene, sometimes called polyvinyl chloride. When we talk about the polymer, so the monomer is vinyl chloride. So the polymer is polyvinyl chloride, PVC. You might have heard about PVC pipes. Those are made from vinyl chloride. So as you can see the structure, from here you can see the repeating units. So if you are asked to draw the repeating units, this is the way you have to represent the structure. If you are asked to draw the structure of the polymer, this is the way you have to mention. As you can see, all the addition polymers, the base carbon is the carbon that is having the double bond. Always there will be 2 carbon. If you don't add N, yes, that will be wrong. Make sure that you add N. If the question is asked to draw the structure of polymer, then you have to add N. But if the question asks to draw part of the structure, that means draw 3 repeating units of polychloroethene, for example, then you have to draw 3 repeating units like this without N. In that case, you must not use N. Okay. What is the use of N? N is a whole number. It means the number of repeating units. What's inside the bracket is repeated n times. Since, yes, how many repeating units it is. Since it depends on different situations, different reactions, that's why just n is written. So when identifying the monomer, we identify a repeating unit. If it has two carbon atoms side by side in the main chain, you could draw a bracket around it. So that's what we mentioned like this. So identifying the repeating units, you have to look at the structure that is given in the question, and you have to see which part is repeated. And if you ask to draw the structure of the monomer, we take part of it, and always we know the two carbon that is written in the as the base structure, those are the two carbon that will have in the double bond, right? So we introduce two carbon with the double bond. Now this time we don't introduce the continuation line. Instead, we write all other bonds that is mentioned in the repeating unit. So CH3H. So usually from the polymer structure, you may be asked to draw the structure of monomer, or when giving the monomer structure, follow the same step which I mentioned before to draw the structure of polymer. Clear? Now we are going to start condensation polymerization. Now in condensation polymers, hold on. One student got disconnected. Mustafa, what happened? Why so late? Hello? Mustafa? Did you got disconnected? You there? Yeah, what happened? Why is late? You are 15 minutes late. What happened? Okay. Yeah, these days internet issues are there. But, but make sure that you uh, get online before time, okay? Before around 15 or 10 minutes, if you get online, then you can sort out. Yeah. So we will continue. Sorry about that. So condensation polymers are formed when monomer molecules are linked together to form larger molecule, and there will be an elimination of smaller molecules such as H2O, water. Sometimes it is not only water, sometimes small molecules like HCl or HBr. So small elimination of small molecules, but usually it's water in most cases. We will look at some of the examples. That means usually in condensation polymer, the monomers that is used, they are not identical, which in addition polymer, the monomer is identical to each other. So if it is ethene, all ethene molecules join together to form polyethene. And when they combine, they have, what we are focusing is not the whole structure, but only the functional group. All right. So we will look at what that means as well. Now there's another concept called hydrolyzing. This is just the opposite of polymerization. Polymerization means combining monomers, right? Hydrolyzing means breaking down of a polymer to form monomers. So in that case, we add water instead of formation of water in polymerization, that is in condensation polymerization. So in order to do that, we have to add water in acidic conditions. So usually hydrochloric acid or sulfuric acid is used. Let's take a look at to nylon, how nylon is formed. Now, to form, when we talk about nylon, we have to know the first is about the monomers. Now, just by looking at the structure, you might feel that it's so scary, right? But what's this part is not important. All this CH part, we can represent that as a box, and we can write the same structure in this manner. NH2, NH2. For the next one, COCl, C double bond O, Cl. Now the structure is much more simple, right? The thing we have to be concerned about is the functional group. So if you look at the name, one is a diamine. Okay, one is a diamine. The another one is a dioil chloride. Sometimes dicarboxylic acid is used. In that case, instead of chlorine, it will have OH. Both sides also, instead of chlorine, it will have OH. So in this case, we will check what's given here, which is the chlorine. Let me erase this. So we have chlorine on both sides. So what you think will happen here? As we mentioned before, when two monomers combine, it eliminates small molecules. In this case, what you think the small molecule will be? Looking at those functional group. For diamine, the functional group is NH2. NH2 means amine functional group. And this one, the functional group is C double bond O, Cl. Can you tell me what you think will be eliminated from this structure when these two combine? Is it H2O? So H is coming from where, Saudan? From where you think H is? From the amine. So let's circle the amine. So if it is H from one amine, the other side amine H also will be removed. Then what about the other structure? What about the chloride structure? Which one will be removed? Is it carbon oxygen double bond or CCl, which will be broken? Anyone? Can anyone tell me? Okay. Remember when we studied esterification? When esterification, alcohol and carboxylic acid combine, alcohol is having OH and carboxylic acid is having C double bond or OH. From the carboxylic acid, which bond was broken during esterification? From the carboxylic acid, alcohol, Did you forget now? The OH bond. From the acid, OH bond was removed, and from alcohol, the oxygen and hydrogen bond was removed, right? So the priority is given not to the carbon oxygen double bond. Usually that bond is not involved in most of the reactions. If any other bond is attached with the carbon oxygen double bond. So here in this case also, instead of C double bond O, the Cl will be removed. So if we take a look at the structure, these are the functional groups mentioned. And if you take a look at the structure, the the small molecule that is removed in this case is not water but HCl. So that's what I want to highlight. Sometimes in the case there will be, instead of chlorine here, there might be OH. In those cases, in that example, the small molecule form will be water. All right, so you have to be careful with the structure given. Usually the monomer structures will be given like this: monomer A, monomer B, and then you have to work out by drawing a rough circle like this. You have to work out the answer. Okay, and when you combine, make sure that you are combining from where the two bonds are broken. No, you don't have to learn naming. You just have to know how to draw the structure of the polymer when the structure of the monomer is given, or you have to know how to draw the structure of monomer when the polymer structure is given. Both cases, both ways you have to know. Okay, so in this case, that means in this structure, the first hydrogen will be removed. This hydrogen is removed from the second NH. This chlorine will be removed. So that means from the other structure, another chlorine will be removed as well. In this structure, that process, the remove of this process is not shown since this is only the first step. Okay, so here you can see another A reacts here and so on. So they have only shown the first step. But when we draw the structure of polymer, we mention, so as you can see, this first hydrogen bond is broken. Let me color the elements that is removed. So now you can combine. So the first one, NH, then there's a box. This box represents the carbon hydrogen chain. Okay, long chain of carbon hydrogen. And then we have an H here. Then what happened to the top H hydrogen NH bond? That bond is broken, right? That bond will combine with the one which is removed, that is CCl bond. So that bond is bonded to the C double bond O, this carbon, and then we have the box, and then C double bond O, then continuation line. We include the bracket, and then we include N. This is the structure of nylon. This is how we draw the structure. Identifying which small molecule will be removed, you can use a pencil to shade, and then combine those two monomers in this manner. And after combining, there's another key point that you must know, that is this part, the NHC double bond O. This is called amide linkage, sometimes also called peptide linkage. I think you have come across peptide in biology when you talk about protein. Do you remember? Proteins are made from uh, amino acids. They have one side amine, the other side acids. So it is elimination of water molecules. Polypeptides, yes. Proteins are polypeptides because they contain, protein is a polymer that contain peptide linkage. That's why they are called polypeptides. Okay. So this identifying of amide linkage, this is how you know whether by looking at the structure of polymer, whether that substance is condensation or addition. If the function, if the linkage, whether it is amide, in your syllabus there will be two linkage that you must know, amide or peptide, and the other linkage is ester. If those two, among those two, if one linkage is there, then you can straight away, you can finalize that the polymer is a condensation polymer. Okay, that's the difference between an addition and condensation. The main difference from the structure you can identify like that. Now another one is pterylene. In pterylene, as you can see, this is a very scary structure, right? But the important part here is the functional group. If you take the functional group, you can represent the first benzene structure, benzene 1,4-dicarboxylic acid. You can just mention it is a dicarboxylic acid. So this part you can represent as a box, which means you can draw the structure C double bond OOH, box, C double bond OOH. And the second monomer also you can represent the middle part as a box. So OH, OH. You have to remember the monomers, okay? For pterylene, specifically for pterylene, you have to remember. Sometimes they may give the name. What you have to remember is for pterylene, it will be a dicarboxylic acid, which means there will be two carboxylic acid functional group, and the other one is a dialcohol or diol, which means there will be two alcohol groups. All right, if you learn that much, then that will be fine. So if you take a look at the structure, like what happened in nylon, here in this case, since it is an acid and alcohol, it will be an esterification, right? So that will be an elimination of OH from acid and H from alcohol. So here in this way also, H from the other side, H from alcohol, those will be removed. So that's color it. So when you draw the structure, first continuation line, that is this bond, the bond that is being broken, carbon, oxygen double bond, the red box, C double bond O, the bond that is being broken with the OH bond is connected to the O, which was broken, the OH bond before is combined, and then the yellow box, and then the oxygen and OH bond is broken, that will be the continuation line. We include a bracket and then we include N. This will be the structure of, yeah, this is not that hard. It's very easy. You just have to think in a sequence manner, in a step by step. if you think in that manner, it's very easy. Actually, chemistry is very easy, believe me. So the one which you have to highlight here is this part, which is called the ester linkage. So previously amide linkage, here ester linkage. And if we when we talk about synthetic polymers, the following will be natural polymers. You will be having you will have to link the idea of linkage to synthetic to natural polymers as well. Like nylon, since they have peptide linkage or amide linkage, the natural molecule that have the peptide linkage is protein. And terylene is the one which is having the ester linkage. The natural molecule that has the ester linkage will be fats. All right, fats or oil, and that I will be discussing as well. All right. Well, it's not exactly 2 moles. It depends on the question. Okay, so we just mentioned H2O. There is no specific way we know that whether it is 2 or 3, because we don't know how much monomers will combine. So it's just one H2O or one HCl. We don't write N either. So nylon you can make in the Score lab if we have the specific material. We just need two, that is a amine and a dicarboxylic acid. If we have, we can make nylon. And when those two mix together, there will be a layer that is having a little bit higher in density, so uh, it will form a layer in between those two liquids, actually specific density, and you can remove that layer as wires or threads. Yeah, it's zinc, but it's zinc between the two compounds, that is two monomers. Okay, where those two meet, the surface of those two. And usually nylon threads are very strong and tough, so it has many purpose. And fibers of nylon and terylene are made by pumping the melted polymer through a spinet. It's like a shower head. Okay, as it comes out through the hole, the polymer hardens into long threads. So as you can see from the diagram, and most of the shirts made from terylene woven with cotton, so to make the shirt more durable. And the reason why, now many people say that plastic is bad. It's no single thing is bad by itself. It's how we use something that is bad, how we handle it. It is if we make anything that is compulsive, if that become a compulsive behavior, then it becomes destructive for us. So plastics have advantages and disadvantages as well. Some of the advantages, they it does not conduct heat and electricity, so you can use that as an advantage as well. They are unreactive, so they can be used, they are not affected by air, water, and some plastic, they actually can withstand even concentrated acids. As you may have seen from the laboratory, there are concentrated sulfuric acid is actually, it is placed inside a plastic, a specific kind of plastic bottle. So that since they are unreactive, they are safe to store things, including food. Um, they are light. They are actually lighter than wood, stone, or any other material available, especially metals, and they don't break easily, even if you drop them. They are strong. The molecules have high, strong covalent bond, so it's hard to pull them apart. They do not catch fire easily. Actually, some plastics they catch fire easily, but they are a heat resistant plastic as well, especially the handle, uh, the pans handle. It is made up of a special kind of plastic, so it can be used in the insulator as well. So this table you have to know, this is important. All right, sometimes question asks to write some uses for some polymers, synthetic polymers. So polythene is the one which definitely will be important. PVC is important. Polypropylene is important. Nylon and terylene is important. Then for polystyrene and Teflon, I suggest you remember at least one use. Okay, but for others, the uses that mentioned will be important for you to remember. Now, before we go to natural polymers, let's take a 5 minutes break. Okay, everyone here. Very good. So we will proceed. So natural polymers, we'll be learning about proteins, carbohydrates. First thing you have to know is we have to know that proteins and carbohydrates are one of the main constituent of foods. So that will be very easy. And then we have to describe the proteins, carbohydrates as its linkages. All right. And we have to learn about the structure of protein. So usually the structure of polymer will be depend on the structure of the monomer. So that means we have to know the structure of monomer as well. Describing the hydrolysis of protein, that is the opposite process of polymerization, hydrolysis. And we will learn about the carbohydrates, similar like proteins. And in addition to that, we'll be learning some information about chromatography in separating and identifying the products of hydrolysis of carbohydrates and proteins. Now, let's take a look at the carbohydrates. As you know, carbohydrate is the main process in which that provides energy for us. Carbohydrates, all carbohydrates will contain carbon, hydrogen, oxygen. In fact, carbohydrates, proteins, fats and oil, all these compounds have carbon, hydrogen, and oxygen. There are simple carbohydrates and complex carbohydrates. You might have learned about monosaccharides, disaccharides, polysaccharides. Have you? In biology, you have to learn the examples as well. So some of the monosaccharide example, can anyone tell me a monosaccharide example? Like glucose, fructose, those two are simple carbohydrates. Complex carbohydrates like polysaccharides, such as starch and cellulose. All these combine to form condensation polymers, which means it is removal of small molecules like water. So if we take a look at the structure of a carbohydrate, so this is one of the famous structure of glucose. It is C6H12O6. Can you see this structure? It is a cyclic structure, C6H12O6. You can see it contains OH. Yeah, it looks confusing. Yes, I know. But look at the structure in this manner. If you look at the structure in this manner, then it is a cyclic compound. So it has only one ring. Is a ring structure. So if a carbohydrate has a ring structure, if a simple sugar molecule has a ring structure, that is considered as monosaccharides. Okay, I think you might have learned the definitions of monosaccharides in that manner. Mono means one, di means two, like that. All right. So you don't have to learn the structure of glucose in this manner. So you can see there is so many OH, right? So we can represent the same structure in a different way. How? What we do is we take bracket for everything that is other than the functional group. The functional group here is what? Can guess? Can you guess? What is the functional group? There is 1, 2, 3, 4, 5 functional group. OH, exactly. So we take everything else inside the box and we take OH. So a simple sugar molecule or glucose molecule can be represented in this manner. Yes. So what we do is we can draw the glucose molecule as shown here, and then we can draw another glucose molecule like that. And just like we mentioned previously in condensation polymerization, we take OH from one molecule and H from another molecule to eliminate water. And we go on adding like that according to the question. If, for example, if the question is asking you to draw 3 repeating units or 4 repeating units, this will be the answer. Okay. The main idea is, in this case, usually when we draw the structure, there will be no bracket n, all right, in carbohydrates. Usually the questions will be asked in terms of repeating units. That is usually most of the questions I have come across. It will be repeating units. So what we first do is we take glucose molecules in this manner. We take OH from one, so it can be any you choose. We can take OH from the first one, that means H from the second. Yeah, in this case also, if you take OH from both sides, OH will be there. If we take H from both sides, H will be gone. And then we combine the molecule O. This is the way we represent the structure for carbohydrate. Okay, simple sugar molecules to form carbohydrate. So the carbohydrate here in this form To be specific, it will be a disaccharide, right? Two sugar molecule join together to form a disaccharide. Now, if you take the opposite process of polymerization, that will be hydrolysis of carbohydrates. So this means complex carbohydrates can undergo hydrolysis and produce simple sugar molecules as the monomers. So this can be done by using concentrated hydrochloric acid. Make sure that you mention concentrated hydrochloric acid is very important. And we heat under reflux. Heat is also there as the condition. This is actually happening in our digestive system. Starch and any disaccharide gets broken down to glucose. Your cells then use this glucose to provide energy in a process called respiration. It is the reverse of photosynthesis. So you need to learn this equation, the respiration equation. I think you might have come across during air pollution as well, the air and atmosphere topic. So glucose plus oxygen given rise to carbon dioxide, water, and energy. Glucose is broken down into carbon dioxide and water and energy. Now, when we talk about proteins are again condensation polymers which are formed from amino acids. Amino acids, even in the name itself, which means there will be a long structure, and at one end there will be amine group, which is NH2, and the other end it will be an acid group. That's why it's called amino acid. There will be amine group and acid group. So when one amino acid reacts with another amino acid, what do you think will happen? From the amine group, which element will be removed? Hydrogen, right? And from the acid part, yes, OH will be removed. So here again the same pattern, H from amine, OH from acid. So you color, you shade what's been broken as in a nylon structure, yes. And then we combine the NH, C double bond O, then the broken bond will be combined with NH, C double bond O, continuation line. So this will be the structure for protein. This is protein. And as you can see, just like nylon, it has C double bond O, NH, which is the amide linkage. That's why nylon and protein, they have same linkage, amide linkage. All right. I hope you will know if the structure of nylon is given, then you should be able to, if the structure of monomer is given, you should be able to draw the structure for protein as well. So the difference between carbohydrates and protein is this one. In addition to carbon, hydrogen, and oxygen, proteins have nitrogen and sulfur. So this nitrogen is sulfur coming from different kinds of amino acids, right? That's why protein has nitrogen and sulfur. So this is different kinds of, you can see the structure of different kinds of amino acids. All these, the structure is different, but What's similar is the functional group on both end, right? Acid group at one end and
Just
acid group at one end, the another amine group. All right. So we have only a very little portion, but it's 3 o'clock, so we will finish. So up to here, anyone have any question? So if you don't have no question, if you don't have any question, we will finish. But before you go, you have to give, if you understood all the concept that we have discussed today, give a thumbs up. Okay, give a like. If you do not understand, give a thumbs down. Okay, that will be our exit ticket. Once you do that, you can sign off. I will give a schedule for night class. Tonight sometime I will upload it. You can suggest which days will be most convenient for you. You can comment on that one. All right, so that I can change the schedule according to your preference. Okay, give a thumbs up from the thumbs up icon. Okay, 25 students are there, only 17 have given the feedback. How many days are we taking? You mean for the past paper class? For the past paper? You mean regular night class? Oh, night class we will take maybe 2 or 3 per week. I think 2 will be fine. Every day afternoon from 2 to 3 we are having regular class, right? But in addition to the regular class, I am planning to conduct night classes as well from 9 to 10 for us to practice past papers. So night class will be practicing only past paper questions. So the idea is this: I'll give you time to do a specific past paper. Okay, for example, 2016 paper 2, and uh, all students will come to the night class being ready, finished with the answers, and can we have a little early? Oh, you mean 8 to 9? Well, let's decide the time in a poll. All right. Yeah, you have to eat. That's true. I also have to eat. And you have to get some time to get ready as well.